Hello, everybody. I'm Sasha Segan from PCMag.com, and welcome to Hack to School, a partnership between Lenovo and PCMag that will introduce you to the basics of coding and hopefully inspire some of you to pursue a career in computer science. As part of this partnership, we have placed Lenovo Yoga 910 laptops in schools with teachers from the 4th to 12th grades. Joining us today are students from Kensington High School in Philadelphia, Bayonne High School in Bayonne, New Jersey, Lakeview High School in Chicago, and many others from all over the country. Also joining me today is JonAlf Dyrland-Weaver, the coordinator of computer science for Stuyvesant High School in New York City. In a few minutes, John is going to give us all a lesson in computer coding. Using what?
We're going to be using NetLogo again. We started off with NetLogo last week, and I'm going to show some new things in it. And excited to go through some more steps and do more advanced stuff with it.
Okay, terrific. And we'll definitely figure out what is going on with these huge swords. These are real-life giant swords that we will be coding with. It is coding with swords today. So this is lesson 2 of 3. We had lesson 1 last week. Lesson 3 will be next week. Of course, you can replay lesson 1. You can replay this lesson as well. They're all available for replay. Let me tell you quickly how this is going to work. So first, JonAlf is going to give you lesson number 2 in coding with NetLogo this week with more swords. If you have questions, please let us know in the comments section where I will ask JonAlf between his lines of code. Just keep them educational and coding related, please. And then finally, if you want to stick around after the coding lesson, we're going to have PCMag's robot expert, Will Greenwald, come in and show you what exactly is going on here. This is LittleBits, a really cool robotics and electronics kit, and we will get a demo of it from Will. But first, let's dive into NetLogo. Why do we have swords here, and what are you going to do with them?
Well, we're going to do some cool stuff with swords. Stores? No. But we're going to get to them later.
Okay. I can be a tiny bit patient.
Yes. We'll get back to swords. We're going to do image stuff in NetLogo. It's going to be great. So let's go to a fresh NetLogo program without any swords. Don't worry, they'll come back. So last week we covered turtles, and we had them move around. They were drawing squares and doing all sorts of cool stuff.
Like rainbow fan.
Yeah, that's crowd pleaser. Today we're going to look at the other kind of agent in NetLogo. This is, in NetLogo, the terminology we say agents. Turtles are agents that move around the screen, and there's these things called patches, which make up the background. Okay? And I want to mention that at least until we get to the swords, because you need to have the sword picture, and I don't know if everybody has that one, but until we get there, the things that I'm doing, if anybody's watching and running NetLogo on their own computer, they can follow around with these commands and see what's going on. It'll be a lot of fun. So when you see NetLogo, right, this is what we saw last week, and we have this big black area, not a lot of interesting things going on, no turtles. So what we're going to do is, if we go down at the bottom of the command center, you might recall last time, I did things with the observer context. That's how I made turtles. And then I went into the turtle context to command the turtles to do things. They do my bidding. We're going to go to the patches context. All right? So patches make up the background of the world. And basically, the one thing we can do with patches, which doesn't sound like much, but you're going to see there's a lot we can get out of this, is change their color. So patches have colors. And if you, I don't know where my cursor went. There we go. We can change them. I can say set P color red. And the background became red. Now, you may recall last week I was using color to change the turtle's color. It's P color because we can't use the same word twice. So P color for patch color. That's all. So I set the P color red, and now it's red. And then I can say, I don't know, set P color to 84. And it's this, I don't know, sort of turquoisey shade. So what's going on with colors, right? In order to work with patches, we're going to do a lot of work with colors. And so we want to know how NetLogo represents colors. Now, NetLogo is not perfect, and this is actually one of the things that I wish was a little more like the rest of the computing world. So most of the computing world does colors in red, green, blue, triple values. NetLogo does something a little different. And to look at that, if I go to the Tools menu here, color swatches, just like, I don't know, you're going to paint your living room or something, and you go to the Home Depot or whatever and get some color swatches. So here are the color swatches. And so when I set the P color to red, there's red over there, and you'll see all these shades of red. And it says red equals 15, right? And then when I said set P color to, what is it, 84, well, I can find 84, that's right here, and that's a version of cyan. So colors are just numbers. They go from 0 all the way up to 139.9 is sort of white by the pink over there. So that's how we deal with colors. They're numbers in the range 0 to 140, basically, and we're going to mess around with patches. So right now, you can't really tell how many patches there are. It looks like there's just one big patch, but there's not. And so what I can do is I can tell all the patches, set P color, to change their color to a random value. Getting random numbers is very common in lots of languages. Most languages have some kind of random function. In NetLogo, you say random, you give it a number. I'm going to say random 140, and it's going to spit back a random, well, it will give back a random integer between 0 and 140, and every patch is going to run this command. And now we see there are, in fact, quite a few patches. And so each patch ran this command on its own. So that's the, right, just like we had every turtle run their own version of the drawing square command or whatever we were doing, the same thing happens. Each patch is going to run this command, and we see lots of different colors. And now we see that there are, in fact, many patches out there in the world. In fact, the default NetLogo world is 33 patches by 33 patches. So we get it's like a little bit over 1,000, I believe, patches total. Now that we see all of these patches, we're going to look at another sort of standard computer science feature, programming feature. So I'm going to reset everything. Let's do set P color. I don't know. Sasha, you got a color for me?
Yeah. Should I just pick a number?
Sure.
56.
56. Sounds good. Set, of course. Why does it keep doing that to me? I don't know. All right. 56.
Oh.
Well, sure. Set P color 56. There we go. It's this nice shade of green.
Now, when you were setting the colors as random,
Yeah.
you said that random was generating an integer, but it looked like the colors could be decimals, right?
Yes, the colors can be decimals. They can have, well, in programming, we like to call them floating point units. And we can do that, but there is a random function that gives random floating point numbers as well.
Okay.
So we can get there. Great. So here we've got P color 56. The next thing I wanted to show is something that you need to do in computer programming, and that is make decisions, right? You say, all right, if this thing is true, I want to go one way. If this is true, I want to go the other way. Like this happens with robots. This happens anywhere. So we're going to see what we call the if statement in NetLogo. And many languages have some kind of conditional statement, and it's for decision making. So I can say in patch context, if, let's see, so patches, in addition to having color, have coordinates, just like kind of in math class, an x coordinate and a y coordinate. So I can say if px core equals 0, and this is a test. Basically, every patch is going to ask, is my px core 0? Most of them, that will not be true.
So your patches do they go from 0 to 32, basically, or is it more exotic than that?
I don't know if I'd call it exotic. It's actually similar to in math class, where your axes go around the center of the world.
Okay.
That is modifiable. You can change it. So if px core equals 0, let's set p color, I don't know, let's go pink. Great. And notice I put these, the command in square brackets. That's just a syntactic rule. You got to do it. So if this is true, set p color pink. And so we see everything with an x coordinate of 0 became pink.
And so now the stuff to the left would have negative x coordinates, and stuff to the right would be positive?
Exactly.
Okay.
Yeah. And, we can run this again, and instead of doing the x coordinate, we could say the y coordinate, and there. Now we know, right, these are all x coordinate zeros, these are y coordinate zeros, and there's our middle.
It's super like your graphing calculator.
Yeah, exactly. So we know how that sets up. And now we've got the if statement. I mean, I'm not going to do a lot of if work right now, but it's just, once you have this, you can now have programs that do different things, right? That's a huge, making decisions in code is really important. Now, we're going to, let's reset, set p color 56. Great. And right, if you're sort of following along, you can see all the commands that I have here in the command center, so you can see what's going on. So I'm going to do something a little different. So I had this if pxy. No, that's not a thing. If px core equals 0, I said set p color pink. I'm going to add a new another wrinkle to this. So the thing is, what happened to all the patches that weren't on the x core 0? There was no command. They didn't do anything because I didn't tell them to. Fine. But we can include a new command called if-else.
And that's different from a standard if.
Yes.
Okay.
And so if-else also has a condition, px score equals 0. We're going to use the same one. And the first part is the same as before. Set p color pink, exactly like we did before. But now we're going to add a second set of commands inside another set of square brackets. And now I'm going to say set p color sky is one of the colors. It's nice. And so what's going to happen? Well, let's see. So notice we got our pink row of patches down the bottom, down the middle, and then everything that was not covered under px score equals 0 became blue.
Now, I'm just curious, could you put the words then and else in there if you wanted to make it more readable? Are those optional?
No, you cannot use the then and else, unfortunately. Yeah. So the syntax, and this is, every language has syntactic rules.
Yep.
And in NetLogo, we say if else if we want a one or the other options, right? If else means we test. If it's true, we do the first thing. If it's false, we're going to do the second thing.
And now, can you only have one thing in between each set of brackets?
No, we can actually do a lot if we wanted to, but with patches, so with turtles, that would be great, because you can have them move and rotate and do a bunch of stuff. Patches, we would just have them change color.
Okay.
And so, like, I could say set p color pink, and then set p color something else, but we wouldn't see that. It would happen so quick, right? And so now we've got an if statement and an if-else statement. And there's a lot of cool things we can do now that we can make decisions. And as I just mentioned, these are control statements. You can use them with turtles if you wanted to. You can say if the turtle is above the x-axis, do one thing. If you're doing a game and if you fall too far below, you lose a life, well, you can say, hey, if you're too far below, lose a life.
So then it's almost like giving your turtles behaviors or intelligence so that they can know what to do in different circumstances.
Exactly, yeah. So this is all great stuff. And so that's the sort of if and if else. I know I just did this kind of quickly, but you can play around with this and make all sorts of interesting decisions. Now, we want to get back to those swords, right? And so that's the next thing I want to talk about, because there's this really cool thing about patches, and that patches are just units of color, right? Which is very similar to images, right? If I could bring images into the NetLogo world and modify the patch colors the way I normally do, I could do image manipulation in NetLogo. And so that's what we're going to look at next. So actually, I have to go to the observer context. And there is a command called import every time.
And now observer is your God mode. It affects everything, right?
Yes. The observer can do whatever they want. Import p colors. And then I give it the name of a picture. And I cleverly named it swords.jpg. And the name has to go inside quotes. It's what we call a string in computer science. And it might take a moment. Oh, it didn't take a moment. Wow,
That's
so fast.
Very blocky.
Yes. So we've got this swords picture, by the way, if you're going to run this, at home or at school, when you load an image, this is a little technical thing, the image file must be in the same folder as wherever you saved the NetLogo file. Otherwise, it won't know where to look. So you save your NetLogo, you save it, let's say you do it on your desktop, save the image on your desktop, and it'll be there. So the problem with this, right, this doesn't look like the swords picture we had at the beginning of the show. That's because the patches are too big. Right?
It's a 33 by 33 grid, as you said.
Yeah, and that picture is not, our cameras don't take 33 by 33 pictures anymore. We're pretty good. And so what we want to be able to do is increase the number of patches and at the same time shrink them, right? And so we can, in fact, do that. And I'm going to go back to the swords. That looks a lot better. Right?
Yeah, it's almost like the patches are pixel by pixel.
Indeed. And in fact, that's what they are. So new fun NetLogo thing is that there's this button up here called Settings. And if I click Settings, I can control the overall aspect of the world. And so here you see this representation of the world, and you'll notice, it's a little small. Hopefully we can zoom in here. I've done a few things. I've moved the origin to the bottom left-hand corner, and that was just easier to match the dimensions. Instead of making it 33 by 33, I matched the dimensions of my picture, and it's now 750 by 500.
Oh, wow.
And this is important. So I made more pixels, and I shrunk the patch size to 1 pixel. So now there's a one-to-one mapping from pixels in my image to patches.
So now your patch commands will be able to affect individual pixels in the picture.
Exactly. So I don't need, I set this up beforehand, but you can do this on your own if you have an image and you load it. And I can click OK. Now, one thing I will note is once you increase, I now have like something around 300,000 patches. So it's a lot more doing work. So when I run the import pcolors command, swords.jpg. Oh, you know what? I did a silly thing, and that is I should have shown you from a fresh start. So I'm going to clear all. Notice how it didn't clear all?
Yeah.
It's actually waiting to do the swords.jpg import.
Oh, okay.
Because it actually now we did clear all. So I did want to show, like, you're going to do this at school or at home. Don't be frustrated if it takes a little bit of time. It's just NetLogo is not designed to be a super fast language. And like I said, 300,000 calculations.
Yeah, but also if they're using those Lenovo Yoga 910s, it's not going to break as well.
Right. It's not going to take too long. So now I'm going to do import pcolors and just give it a moment, and it will load the images here, or the image. There aren't multiple images. Once it loads, here is a couple things. I'm going to show something that everybody should be able to follow along with, and then I'm going to go perhaps a little bit more advanced, just in case anybody's like, ooh, this is really cool, what can I do? So, let's say, I don't know, I don't like the color of the sky. It was kind of like a gray day when I took this picture, and so I want to change the color of the sky. So one thing I can do, you can right-click on any patch and see Inspect Patch, and over there it says, the color, pcolor, 109.8, right? And the other properties. So there are lots of other properties we won't get into. So I can say things like, using my if statement, well, let's go to patch context, if, and I will do something like pcolor, I'll do a range, do like 20, so I'll go like 90 to 110.
So that way you don't get exactly that shade of gray. You get like all the similar shades of gray.
Yeah, whatever is going on in there. So if pcolor is greater than, let's say, 90, now if I want two conditions, I can combine them with and.
Okay.
Just like that. This works if you've done logic in your classes, and or not all work just like they do in logic. So I can say if the pcolor is greater than 90 and the P color is, let's say, less than 110, I can set the P color. I don't know, what would be a better sky color?
Didn't you say there's a color called sky?
There is set P color sky. And
whoa.
There we go. Now, it's not perfect, but I've just manipulated this image, right? I just said, let's replace colors. You see, like, the weatherman does green screen effects and things like that. Similar idea, right? Just say, oh, there's green in the background. Let's replace it with something else.
I get the feeling that you could actually write image filters
Certainly
in
can.
NetLogo.
Yeah, certainly can. And in fact, we're going to be finishing up here soon because we got the robots to come to and lots of cool stuff. And so it might be really cool if you guys are playing with this at home or at school to see if you can load images and do some filters, you know,
Load pictures of your face, do crazy things with them.
Yeah,
Absolutely.
yeah. Snapchat filters, whatever.
That's
you can
what
do
I'm
this
thinking.
in NetLogo, exactly. And so that's why I wanted to get to the image stuff. It's just patches give you image manipulation, which is a lot of fun.
Yeah.
And in the next session, I'll show one more thing that we can do with images that I like a lot, that I do in my classes, and then some more advanced things that we can do in NetLogo with turtles and patches together. So I think that's good. I've done a lot with you guys today, and I think you're in place to do some really cool things between now and the next session.
It looks like we have some questions out there.
Great.
Okay, we have a couple from Bodine. First, Christina Labella asks, how long does it take to learn a coding program?
I mean, you can, depends. Like, you can start coding in NetLogo or Python or processing or something pretty quickly, right? Like, you open up NetLogo, you can start running it. To master a language takes a lifetime. But to get to a point where you can build something useful, you know, if you spent a little bit of time every day, you'd get there in a week, maybe even less depending on the language.
And something else is that once you know the basic principles, all of these languages, many of these languages at least, share a lot of the same basic principles. So once you have the basic principles down, it can get a lot faster to pick up a new one,
Oh,
right?
certainly. It's like, you know, oh, how do I do an if statement? I know they exist.
Right.
It's got to be there. How do I write a procedure? We saw that last week. How do I do
It's got to have loops. How do I do a loop?
Yep.
Okay, and Jasmine Vargas asked, what are some other programs used for coding besides NetLogo?
Great. So I mentioned just, you know, in passing, I mentioned Python, really popular, really good to get started in programming. It's the feedback is good and the language doesn't get in the way syntactically. Processing is another great one. It's built off Java, and so you learn a real, you know, beefy professional language. Python is also as well, but it does image stuff and graphical things. And then there are lots of languages out there. C is sort of the grandfather of a lot of languages. A lot of things are built off that, and so those are big ones. There's C++. I could list many, many others. There's a lot out there. It really depends on what you want to do. There's probably a language that fits it. No one language does it all.
Okay, and Shamal wants to know, is there any concept of threads and processes in NetLogo? And can you explain what that is?
Sure. So threads is a thing where you have like one computer, one program doing multiple things at the same time, is sort of a simplistic way of putting threads. And NetLogo doesn't really handle threads in that way. That's one of the reasons why the loading of the image took a little bit of time. It's and that's okay, but you do sort of get, you start to get a feel of doing parallel processing because all of these agents are doing something. Turns out they're not doing it at the same time. They're just doing it in succession really fast.
Now, can you assign different behaviors or different scripts to different turtles? And thereby, you know, that would be functioning a lot like threads would be, wouldn't it?
Oh, certainly.
Yeah.
Yeah. So you can learn sort of the concepts of sort of parallel processing and giving particular instructions to particular agents, but you won't get the sort of speed improvement as threading does.
Okay.
Yeah.
Next question.
Okay, and Sequoia Dorsey asks, how can you use NetLogo in everyday life?
Well, we were just talking about image manipulation
Yep.
and doing filters, like that kind of fun stuff. You can build games. You can build simulations. If you're learning chemistry right now, if you're in chemistry class, you could do simulations of atoms and molecules, and that's some of the stuff I'm going to show next week is built-in things. You can run physics simulations if you're in physics, or even biology. Right? You can sort of model the things you're learning in class and see the results in real time in NetLogo, where maybe you don't have access to a chemistry lab or physics equipment.
Do we have any more questions out there? Okay. Then thank you very much, JonAlf. Let us bring out the robot guy.
Yeah.
So we have Will Greenwald here. He is our robotics expert here at PCMag.com, and he has some LittleBits here. What are these? What do they do? And what is going to happen that's really cool?
Well, last week we looked at Lego Mindstorm's sort of basically a brain and motors and sensors that you basically just build onto a Lego kit. This is a lot more granular. LittleBits is an electronics kit where each bit is an input component, an output component, or a logic component, and they basically work in a lot of similar logic as programming itself. You have inputs, outputs, you basically have different things that function as agents responding to your commands. In this case, we have a wireless transmitter bit and two sliding switches, which adjusts the output of the battery to the transmitter, which goes through here, the receiver, and goes into these two motors. So wirelessly, we have a car.
Whoa!
Oh, no.
Hello. And
They're also pretty rugged.
it shattered into many little bits. There you go.
Yeah. And
okay.
Nice thing about LittleBits, each individual piece is pretty rugged, and they connect magnetically. You should use the pegboard to keep them together, but basically you can just move them all around. And
Yeah, I think that's part of the key.
Yeah.
They're just magnets.
Yeah.
They're not like they're
Very-
not permanently attached in any way.
Yeah, very helpful that way. This is sort of working with electronics on a higher level than if you were soldering and using individual circuit elements yourself. It's like, this is, say, using C or NetLogo or any higher level programming language compared to like binary or assembly, where you need to run each wire and each component to build the circuit from the ground up.
I was going to say, like, I know a lot of schools, especially middle schools, are doing stuff with snap circuits right now. And
this is sort of a more advanced version of the snap circuit, because instead of, you snap together a resistor and a diode and things like that, you have purposes for each bit. A transmitter, a buzzer, a light, and it basically lets you work on these things, sort of plot them out better in your mind as a device you're building, instead of having to get into the nitty-gritty of the individual parts. It's high-level and low-level programming.
But you also have far more advanced components here. Like, you've got these radio transmitters and
well, this one, for example.
What's going on there?
This one is one of the newest LittleBits. This is the Bluetooth Low Energy bit, BLE. And what it lets me do is it works as logic bits are sort of a little bit input, a little bit output. And this can work as either one. It's flashing right now, but I can connect it to my...
You want me to hold it up for you?
Yeah, sure, if you can hold this up. I will just...
Is this going to control your iPad, or is your iPad going to control it?
A little bit of both.
Okay.
For starters, there's the slider, which I can connect manually to the thing right here. And it gives me a sliding switch that controls the output, which... sorry, can you hold this?
Yeah.
You need far more hands.
Yes.
Okay.
If you get really close, I can actually move this servo through Bluetooth. And obviously servos are sort of the building blocks of robots. You need to have this limited specific motion to have robots move at all. I mean, you can give them wheels too, but you can also just set up wheels with that.
This way you could control your robot or your car from your iPad.
But it also lets you set this as a readout. See, this pink bit is a light sensor. So right now it's getting light. Okay, why isn't this work? Okay, well, it should be working, but...
That's because you're demoing it.
Yeah. I'll just restart this.
Because Bluetooth is so reliable.
Yeah, well, Bluetooth is, this is actually really cool for doing a lot of experimentation, but there are certain things that, here we go.
Well,
The number would go up and down if I could actually get this thing working.
it looks like we have a little bit full of questions.
Yeah.
We had Jasmine Vargas from Bodine asking in, how are hacking coding related to robotics? Why are we using robotics here?
Well, the thing that we will be getting to next week is sort of the next step in the real bridge between coding and robotics. This is the Arduino bit. It is an Arduino microcontroller. If you're not familiar with Arduino, it is basically a tiny computer you can just feed code into, and it handles inputs and outputs. This is the LittleBits version of it, so you can snap it to basically any of these, and you can program it so if the switch goes up, it does a complicated process to change like the outputs of. You can do a lot of different things. There are 3 inputs and 3 outputs on this Arduino, and additional little holes for soldering if you want to get into other individual pieces. And basically, this is how you can sort of build a robot using LittleBits that you can program, because you can have it react to inputs like a light sensor if it's working, and you can have it move a servo and basically say, tell it if it detects an obstruction using a sensor, it should stop moving or do another motion to turn around. And that's the basics of mobility for a robot, having it learn to, not learn, but to not run into things and to do specific tasks. If just these pieces, it's inputs, outputs, you pressing a button, at most you're building a Waldo, a remote control device. But when you're actually programming with Arduino, well, we'll be getting into that more next week, but this is the key that will bring what you learn with coding over into physical devices.
Also going back to NetLogo, basically you can program the turtles in NetLogo with behaviors that you would program robots with. Right?
Yeah, sure. And we learned the if statement today and the if else, and Arduino can be programmed with those sort of decision-making procedures. And then we can say, oh, if, all that stuff, Will mentioned if, in fact. And so, yeah, there's what we're doing here can bridge over to the robot world immediately.
Okay. Looks like we have some more questions.
Sure.
Ken Gauss wanted to know, what app are you using for programming the robots, and is it a different app for each type of robot?
In this case, it's the LittleBits app, which basically gives a direct control through the Bluetooth low energy bit. Can you hold this?
Yep.
For Arduino, there's actually a bunch of different things you can do with Arduino. You can program it with a PC, and there's a whole other suite of tools, because Arduino itself is not actually strictly a LittleBits thing, but again, that'll be for next week. Maybe it'll work this time. Okay, so that's it.
Nope, now we're 0.
Well, no, I set it to dark.
Oh, okay.
Okay, well, it worked totally this morning.
Looks like we have another question.
David Wu from Bodine asks, what happens when you get 2 coding languages confused? Do you ever get stressed out from coding?
Syntax errors.
Yeah, sure. I teach my classes in a couple different languages, and there are times when I'm supposed to be teaching in C, and I write a Python command, and my students let me know immediately. They all laugh. They think it's great. The thing is, it'll happen. And yes, you're going to get frustrated sometimes, but the beauty of programming is you're probably not going to do any major damage, right? You make a mistake, you get a little frustrated maybe, but then you figure out, you get a response. In most languages, you get a reasonable, hey, this is what went wrong response, and then you have a chance to fix it. And so you learn from mistakes so often. Like, it's the best way to learn. Is sometimes I ask my students to do things that I will intentionally break, and they'll be like, wait, why did this break? And then that's okay, why?
But also, the development environments are generally pretty kind to you. I was recently writing a thing in PowerShell when I had been previously writing something in SQL, and when you use single quotes and when you use double quotes in those are different.
Yes.
And so I would be improperly quoting things in PowerShell, and you know what? The development environment just says, hey, check out these quotes. I'm a little confused. And you go and you fix it, and nothing's really broken. And in a worst case, you Google quotation marks in PowerShell, and you get a big old page from Microsoft that gives you all the instructions.
Yes.
Any more questions out there?
Maybe.
I think we may have covered this a little bit last time. What do you think is the best coding language to start with?
Not PowerShell.
Not PowerShell. Well, once again, I've mentioned this the languages a few times today. I think NetLogo is a great place to start, clearly, because we're starting here. I've mentioned processing. I've also mentioned Python. One thing about Python is there are lots of utilities to help getting started in Python. There are online books. There's something called Dive into Python, which is freely available, a great place to start. There are other great utilities. So that's one of the, if you're interested in going into a language that is perhaps a little bit harder to learn, but more prevalent and out there, like nobody's building web apps in NetLogo. So you might want to go Python. But those are really my top 3 to get into things in the world.
Looks like we have another question.
Sure.
Victoria Massery asks, what will happen if you type a code wrong? Does it affect the whole program?
Sure. I mean, I could do that right here, and
type
you know, in NetLogo.
Type some nonsense.
So sure, I could say, let's do set p col ot 6he2 error, illegal number format. Nothing broke, right? It just didn't do the thing it was supposed to do. And so there were actually, so this is the thing that happens. I made a couple different errors. P-colot is not a thing. 6he2 is not. So it decided one of those was the error it reported. So I'm like, oh, whoa, there are no h's in my regular numbers here. So let's go 64. And now I got a new error. Nothing named P-colot has been defined. Oh, yeah, because that's not a real thing. No big problem. And I get to fix that. I go P-color, and all of a sudden it works. I don't want to get rid of the sword, so I don't want to do that.
Looks like we have another question.
This might be our last one. Do you think that coding on a PC is better than coding on a Mac?
Coding is, whatever computer you can code on is great. You know, I always want to make sure that the utilities are available for everyone. Certain computers are better than others just generally, but you should not feel stuck like, oh, I've got to be on one computer or another. Really, some environments are better on certain operating systems, but generally, if you're using especially some of the languages I mentioned, you can do it on various computers.
Okay, that's it for our questions?
Yeah, I think we're all set.
Okay, terrific. So before we go today, I want to give a big thanks to our Hack to School partner Lenovo for making this lesson possible and for donating the Lenovo Yoga 910 laptops to deserving teachers. We're going to be back next week with more advanced NetLogo and what actually the Arduino LittleBit does. In the meantime, feel free to replay this lesson as much as you want and to comment further in the Facebook thread. JonAlf, what are some of the things you're going to get into next week?
So next week, I'm going to do a little bit more image stuff. I'm going to do something called edge detection, and you might want to look into that on your own. It's actually pretty easy in NetLogo. And then I'm going to show, I mentioned how you can use NetLogo in other areas. I'm going to show some built-in programs you can see in simulations that come with NetLogo. And I'm going to show some of the things that my students have made so that everybody out there can say, oh, this is what you can do in NetLogo. This is not just me teaching. Like, this is stuff my students made, and it's really interesting.
Okay, terrific. So we'll see you all next week,
Yeah.
and happy coding.